Hello all, welcome back to this online recording sessions in the deep learning concepts from data science concepts. Yeah, this is Akhil from VNR VJEC working as an assistant professor. So we are going to see today activation functions and loss functions, okay, in this session. Okay, so what are activation functions and what are loss functions, where they come into picture in the entire architecture of neural networks. Okay, yeah, first activation functions. So what is activation functions? So we have seen the neurons, right? So neurons will be communicating with each other in order to transform information, process it and give the output, right? Yeah, it is somewhat similar to biological neuron. Okay, yeah, what is the role of the activation functions for the neurons? Okay, it is similar to the artificial neuron, will also only fire when some of the inputs exceeds a certain threshold. Okay, some if they have some threshold, if they have some energy to process it to the next cell, then only the neuron gets fire and the information will be passed. Okay, so that threshold is monitored by this activation functions, okay, to provide energy to the neurons in order to pass the information to the further successive neuron cells. Okay, so their main role is to calculate and decide the outputs by providing the threshold, okay, energy. Yeah, so there are different activation functions. So if you look into the very first activation function, it is binary step activation function or unit step function. Okay, we can also call unit step activation function. Okay, yeah, both means same. Okay, if you see the graph, see, so for all the negative values, the value is 0. Okay, so for 1, it is 0. Okay, for greater than 0, so for values, see, f of x is equal to 1 for x greater than or equal to 0. For greater than 0 values, we have 1 value. Okay, for all positive values, it is 1. For all negative values, it is 0. Okay, from this equation and graph, you can understand. Yeah, let us see some important points related to binary activation function. So binary activation function used for you can imagine this function is not useful when there are multiple classes. Okay, this is the limitation of binary activation function. So during multiple classes, binary activation function or step function will fails, okay, in providing sufficient energy to the neuron. Okay, so this is one of the limitations. Okay, so another one, the gradient of the step function. Okay, so the gradient of the step function is 0, which causes hindrance in the back propagation. Okay, so the gradient will be also 0. Okay, see, this is the gradient, right? You'll be calculating like this. So the gradient will be becoming 0. Okay, if you use this activation function. So on the whole, if you see, activation function supports in some cases, it is not supporting in remaining cases. Okay, so it is used for only simple data. Okay, this binary step activation function. Okay, so next, linear activation function. So yeah, if you see this linear activation function, it is somewhat advanced than binary step function or unit step function. Okay, so the whatever the drawback, the gradient of the function, okay, that is becoming 0 in the step function, it is overcome here. Okay, because why? Because there is no component of x, okay, in binary step activation function. Okay, so here you see the equation f of x is equal to ax. Okay, a is some constant, so x is some value. You can see here a value is 4, f of x is equal to 4x, and the graph is also, you can see it here. Okay, so with some constant value, we are multiplying the x value in order to get the output. Okay, so by using this activation function, we can overcome the gradient of the function of becoming to 0. Okay, if the gradient becomes 0, what happens? The neuron couldn't process the information and the output cannot be extracted, right? So that is the problem. Okay, that problem has come in step function. Now we are overcoming it here. Okay, yeah. Next, here the activation is proportion to the input. Okay, here seen f of x is directly proportional to x. Okay, so if you remove this proportionality, we are adding a constant that is nothing but f of x is equal to ax. Okay, this is what about linear activation function. Okay, next sigmoid function. Okay, sigmoid and softmax functions are mostly used, sigmoid, softmax and tanh. Okay, I have shared with you all in previous sessions also when a sigmoid function is used. So if you look at that, you see this is the graph of the sigmoid activation function. Okay, yeah, thus the equation is here. So 1 plus e power minus x. Okay, this is the mathematical equation and the graph. Okay, so if you look into the some important points related to sigmoid activation function, it is widely used for non-linear. Okay, it is one of the most widely used non-linear activation function. Okay, this is a non-linear activation function. Sigmoid transforms the values between 0 and 1. Okay, so if you want to values between 0 and 1, then sigmoid is better choice. Okay, so generally for binary classification, so in binary classification we have 0 and 1, right? So for multi classification we have many. So at that time we can use softmax. But if it is binary classification, sigmoid is a better choice because it is giving the values between 0 and 1. Okay, so using 0 and 1 we can classify the object, whether it is if 0 means coming, 0 coming means one object, 1 coming means other object. In this way binary classification can be done. Okay, okay, this is essentially means when I have, okay, this is some more important point also is there. I have multiple neurons having sigmoid function. Okay, okay, so this is one of the important point also, you can go through it if you are needed. Yeah, this is what about sigmoid function. Next, tanh function. Okay, so tanh function, if you see from sine and cos we are extracting tanh function. Okay, so tanh function also generally used. Okay, tanh, sigmoid and softmax. Okay, is similar to the sigmoid function. Okay, the difference between that is, if you see the graph. Okay, so it is sigmoid is like this, right? Sigmoid is like this, but you see the tanh, it is somewhat similar, but the values are differing. Okay, so the only difference is symmetric around the origin. Okay, you see it is symmetric around the origin. Okay, it is whatever it is there here, it is symmetric here. Okay, the range of values in this case is from -1 to 1. So if the values are needed from -1 to 1, we can use tanh function. If you want 0 to 1, we can use sigmoid activation function. Okay, okay, next activation functions, ReLU activation function. Okay, ReLU is one of the important concept in the entire activation functions. So there are different versions of ReLU activation functions also that we can discuss in further sessions when we are talking about vanishing gradient problem. Okay, at that time case ReLU is mostly used to overcome vanishing gradient problem. Okay, so gradient problem is different from vanishing gradient problem. Okay, so gradient means it is approximately becoming to 0. Okay, so the neuron is approximately becoming to 0. Vanishing gradient means the neuron will totally disappear. Okay, vanish, it will vanish. Okay, yeah, ReLU activation functions. Okay, ReLU activation functions, mathematically it is represented like this. F of x is equal to maximum of 0 comma x. Okay, so the graph is like this. Okay, yeah, so let us see the points. ReLU activation function is another non-linear function. Okay, it is also one of the non-linear activation function like sigmoid function, which has gained popularity after 2000. Okay, we have seen in the history of deep learning that including of ReLU activation function after 2000 period, right? Yeah, ReLU stands for rectified linear unit. So the main advantage of this is over other function is that it does not activate all the neurons at the time. So all the neurons will be not activated or will be not fired at the time. Okay, step by step it will be processed. Okay, which means that neurons will only be deactivated if the output of the linear transform is less than 0. Okay, so if the neurons is 0, okay, if the neurons their cell state is 0, they will be not activated and they will be not considered. Okay, which have sufficient energy, okay, greater than 0 only will be considered here, and that too step by step. Okay, so that's why ReLU is the best out of all the activation function in order to overcome problems like vanishing gradient problem. Okay, yeah, when to choose which activation functions. Okay, so we have seen few activation functions. When to choose which activation function based upon the data set or based upon the problem given to you. Okay, sigmoid functions are the combinations which works on classifiers. If it is a classification problem like binary, we can directly go with sigmoid. Okay, sigmoids and tanh functions are used for vanishing gradient problem sometimes. Okay, not totally. So totally, even though we are using sigmoid and tanh, there will be in some cases vanishing gradient problem. In that case, ReLU will be used. Okay, so if you don't want to complicate it, you can directly go with ReLU activation function instead of all this. Okay, but ReLU mostly will be used for hidden layers. Okay, hidden layers. Okay, ReLU function is generally used in most cases these days. Yeah, as I mentioned. Okay, mostly used because it is coming most of the drawbacks of the remaining activation functions. Okay, next, softmax. Softmax you can use. Softmax is not there, but I can share you that softmax is used for multi-classification. Okay, if the multi-classification problem, we can use softmax. Okay, okay. So one more point is also there. So there are different versions of ReLU activation functions like leaky ReLU, exponential ReLU, parametric ReLU, which we'll be discussing in next sessions if possible. Okay, yeah. Next, what are the things that we need to keep remember while using the ReLU activation functions? We are saying ReLU is very important. Nowadays mostly we are using in order to overcome many of the problems that are faced by some old activation functions. So you can we can remember these functions. Okay, you can remember these points. Okay, these are summary of what I have shared previously. Okay, when to use softmax, when to use sigmoid and all. Okay, yeah. Next, we are going to see loss functions. So what does, yeah, activation functions help to fire the neuron to another cell, right? It creates energy. Okay, it supports energy. Okay, to carry out the information to another cell. But what is loss function? Okay, this is also function like activation function, right? But what actually the loss function is? Okay, so it will, loss function will tell us the difference between actual value and predicted value. So actual value and predicted value can be known from these different loss functions. Okay, so there are different loss functions that can be used based upon the scenarios, based upon the data sets, based upon the problematic. Okay, so there are different loss functions that will tell us whether we need to go to back propagation or not. So after calculating the difference between the actual value and the predicted value. Yeah, so what is the exact definition of loss function? Yeah, they serve the metric for error measurement. So they will measure the error. So what is the actual error? Okay, between the true value and the predicted value. Yeah, you can use these links if you want to go through some deep concepts related to loss function. You can visit these links. There is some good description about this topic. Okay, next, yeah, these are the different various loss functions. We have mean absolute error, mean absolute error, mean squared error, root mean square error, binary cross entropy, categorical cross entropy, sparse categorical cross entropy. Okay, so nearly we have 6 loss functions. Okay, so there are many also that are evolving day by day. Okay, so as of now we are going to see these loss functions, and let us see a few concepts related to them. Okay, some information related to them. Okay, so next we'll see, we will also see what is loss function and what is cost function. Okay, loss function calculates the error for single data. Okay, first if you are calculating error for single point, then it is called loss function. This loss function is also called cost function. Loss function is also called cost function if you are choosing for multiple points. Okay, if you are choosing calculating error for single point, we'll call it as loss function generally. If you are calculating for multiple points, we'll call it as cost function. We will call this also error function. Okay, so there are three names for this loss function. Okay. Next, the very first one is mean absolute error. So what is this mean absolute error? So we see we are taking the absolute values. Okay, so we are taking absolute values for actual output and the predicted output. You can see the absolute values. Okay, and we are summing it up. Okay, yeah, that is what mean absolute error. Okay, so mean absolute error is one of the loss function used in regression problems. Okay, so for generally if the problem is, if our machine learning problem is type regression kind, okay, then we can use mean absolute error for calculating the loss. Okay, so for linear regression, logistic regression, okay, these are regression problems, right? So for that regression problem we can use this mean absolute error for calculating the error. Okay, so mean absolute error is calculated by taking mean of the absolute differences. See, we are taking difference also between actual value and predicted value, and then we are trying to apply absolute values. Okay, so that is what about mean absolute error. Okay. I think some information is there here. Yeah, there is some few more information also in this slide. You can see what is y, what is n and all. Yeah, next, mean square error. So what is mean square error? Okay, so it is also most popular loss function. Okay, this finds the average of the squared difference. Okay, previously what we have done, we have taken absolute values, right? But here what we are doing, squares. Okay, squares of the actual value and predicted value. Okay, this loss function has various properties, especially suited for calculating loss. Okay, there are few more concepts also, the few more important points that are related to mean squared error. That is, this allows us to more easily utilize gradient descent optimization. Okay, so in order to use gradient descent optimization to set the values, okay, in order to minimize the values by using loss function, we can use mean squared error. Okay, and mean square error is also a convex function. Okay, with clearly defined global minimum. Okay, next, root mean square error. Okay, a mean square error is just a modification of root mean square error. Okay, you see we are just taking the root, okay, of mean square error, okay, of the mean square error. Okay, this is the mathematical formula for root mean square error. Okay, next, binary cross entropy. So what is binary cross entropy? This is also called as log loss. Okay, log loss. So when do we use log loss? When there is a probability. So when there is a probability, okay, probability type of conditions, okay, whether or not, okay, whether it will rain or not, whether it will sunny or not, okay, probability, right? So when there is a probability type of situation, then we can go with binary cross entropy, which is nothing but a log loss. Okay, it is used to calculate the loss of a neural network performing binary classification. Okay, so that is predicting one of two class. Okay, so this is the equation. Okay, for binary cross entropy is set for true and predicted labels. Okay, so you can see here, so the actual formula, okay, which is used for probability kind of problems. Okay, it is used for probability kind of scenarios. Okay, in that case we need to use this loss function. Next, categorical cross entropy. Okay, so this is also one loss function where the number of classes is greater than 2. Okay, if there is multi classification. Okay, so multi classification, when we can go with binary categorical cross entropy. So there are two entropies. So one is binary for 2 and the other one is categorical. So categorical is nothing but a multi-classification like problem. Okay, so this is the formula for it. Okay, it is somewhat similar to the binary cross entropy if you look into it, if you compare the both equations. Okay, yeah, that is what it is mentioned here. Binary cross entropy is a special case of categorical cross entropy, where m equal to 2 minus the number of categories. Okay, yeah, so here m value is calculated. Okay, so on the whole, mean absolute error, okay, mean square error and root mean square error are used for regression problems, okay, the previous ones. Whereas binary entropy, categorical cross entropy, sparse categorical cross entropy are used for classification, as I mentioned. Okay, entropies are used for classifications. Okay, so the remaining ones like mean square, mean absolute error, mean square error, root mean square error are used for regression like problems. Okay, so this is what the based upon the scenario or data sets, the problematic approach, we will be using these loss functions and the activation functions. Okay, so thank you all. So thank you for giving this opportunity. That's it for this session and the topic. Okay, thank you all.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.